Hello everyone, my name is Simisha and I'm an application engineer in Typhoon Hill. Today I'm going to show you a few models. First model is electric vehicle. In this example I will explain you the basic power stage together with control part. First, we are now in Typhoon Hill control center. Now let's use our example portal to find the example. Let's go to automotive, electric vehicle, and let's open this model. For this demonstration we are going to use our Hill 604. Here now we are in schematic editor. In this editor we can create the models and also define inputs to the system. This system consists of three parts. The first one is grid and residential load, the second part is charging station, and third part is electric vehicle. Let's see what we have in grid and residential load. Here we have a three-phase voltage source together with grid impedance, contactor and residential load. The nominal power of this residential load is 20 kilovolts amperes, together with power factor of 0.95. In our charging station we have a battery inverter. In battery inverter, as you know, we have the DC link, we have three-phase inverter together with LC filter. Also there is a control part and contactors. There are also a few measurements here. The most interesting part here is the electric vehicle. Let's see what we have inside it. On our left side we can find the DC link. On the DC link we have a battery. In this example we are using a lithium ion battery. Also there is a possibility to see the discharging curve of this battery and also to define the parameters. Here also we have a two-level three-phase inverter together with LC filter and induction machine. Okay, let's see here what we have as a parameters for three-phase inverter. In general tab we can see that we use an internal modulator. The carrier signal will be generated on the FPGA chip, and from the inputs here we are using signal processing and we are using modulation signal. To control our three-phase inverter we are using internal modulator, and as an input we are giving the modulation signal for the IGBTs. Also there is a possibility to include forward voltage drop and to calculate the losses. Also the good thing here is that we can choose between two switch type, between IGBT and MOSFET. In this case we are using IGBTs as ideal contactors. Also for induction machine, here we can see that we can easily define the basic parameters, also some mechanical properties and so on. Here for control of the three-phase two-level converter we are using the signal processing. In this signal processing part the method that we are using is indirect field-oriented control. And let's see how we actually created this control. Also to describe the behavior of electric vehicle we are using also signal processing. Actually we are defining the torque here that is applied on the induction machine, and we can see that we are also using the signal processing part. Now let's compile this model. Welcome to Hill SCADA. In Hill SCADA you can observe and do some actions on our model. Also, there is a possibility to follow the instantaneous measurements such as currents and voltages using capture scope. Today I'm going to show you a few operating points of electrical vehicles, such as driving mode, where induction machine acts as a motor, regenerative braking mode, where induction machine acts as a generator, EV charging mode, where onboard charger is charging the battery, vehicle to grid mode, where we support the grid from the vehicle battery, and uninterruptible power supplied UPS mode, where we are going to support the load from the vehicle battery. Now let's run the simulation. On our Hill device we can see that LED is blinking, which means that simulation is running. Okay, now let's run the drive mode. To do that, let's go to dashboard and let's start the electric vehicle. We can see that we turn on the vehicle and let's put the throttle on 80%. We can see how the speed is increasing, also together with motor RPM and total distance. Also, there is a possibility to follow electrical and mechanical torque together with active power. In this operating mode, we can see that we are now discharging the battery. Also, there is a possibility to follow the currents and voltages inside the drive system. To run the second operating mode, which is regenerative braking, we need to put throttle to 0. In this case, we will use the energy to charge the battery. Now here we can see that regenerative braking is active and we are charging the battery. Also, there is a possibility to follow the graphs such as torque versus speed and power versus speed. This process will end up when speed goes to 0. Now let's stop the engine. Now let's charge the battery. To do that, we have to choose operating mode, which is EV charging. In this operating mode, the energy will go from the grid to the battery using onboard charger. Now let's check the battery status. Here we can see how battery is charging. Also, there is a possibility to follow the DC fast charging station. As you can see here, we are charging the battery with 150 kilowatts. This can be changed using the slider. The next operating point is vehicle to grid. In this operating point, we can support the grid. Here in status, we can see that we are now in vehicle to grid mode. In this mode, we are supporting the grid with 150 kilowatts. Also, there is a possibility to change that value. In battery status, we can see that now battery is discharging. The last operating point is uninterruptible power supply or UPS. In this operating mode, we will support the residential load. This load is around 20 kilowatts. Here we can see that we are generating power from the battery to the load. Also, we can see that we now discharging the battery. To disconnect the charger, we just need to click disconnect the charger. More information about this model you can find in our application note. To find the application note, go to example portal, automotive, electric vehicle, and open application note. Here you can find more details about our example. Hello again. Now it's time to talk more about how to move to rapid control prototyping from this point. To do that, we need to do 3 steps. The first step is to generate the C code from already existing block. The second step is to define the inputs in our system, and third step is to define the outputs to our system. Okay, let's jump on the first step. So as you can see here, we have a control part. As an inputs, we have the currents in phase A, B, and C. Also, we have a speed of the machine, and also we have a throttle. As outputs, we have a 3 modulation signal for our internal modulator, which are going to be used for the switching. To export this code, the best way is to click the right click, go to C code export, and go to settings. First thing that we need to do is to export to define the path where the C code will be exported. We will choose the C code on our desktop. And also here we can define the platform where we want to export it. For now, we are supporting the generic platform, but in future we can define code for some other platforms, such as Texas Instruments platform. Generic platform can be good as a starting point for automotive microcontrollers such as Tricode and ARM R52. Now let's go to OK and let's export this code. As you can see, the C code exported successfully. Let's take a look on this C code. Okay, now the second step is to define the inputs. The most important inputs in this system are digital inputs. As you probably know, our 604 device has 64 digital inputs. These inputs you can find on the front plate of our Hill device. Now let's define it for 3-phase inverter. To do that, let's go to Control and choose one of 2 possibilities: digital input per switch or digital input per leg. We will go with digital input per switch. Here you can find and define all the digital inputs that you need. Now let's take a look how to define analog outputs from our system. Now let's define the analog outputs from our system. These outputs are currents that flows through induction machine, as you can see here, and also together with speed of induction machine. Here you can find the 3 measurements for 3 currents and 1 probe for observing the speed of induction machine. To define all analog outputs, we have to do it in Hill SCADA. On our right side we can see analog outputs and Hill 0. Here we already defined 3 currents, and now let's define the speed. It is important to mention that here we have to define the scaling also. In this way, we define the 3 important steps for rapid control prototyping. Let's see how it looks using the TI card. Hello again. This is another similar example. Here we're having the drive system for induction machine. As you can see, there is no signal processing part, which means that all control part is implemented in real controller. As you can see here, we are using the Texas Instruments controller from C2000 family. This controller will control the 3-phase inverter. As I said in previous video, we have to just define the digital inputs for 3-phase inverter. Now let's compile this model. This is a Hill SCADA. As I previously said, here we can define analog outputs and digital outputs. Here they are already defined. Now let's run the model. Now, as you can see, the Texas Instruments controller is regulating the speed very well.